Good morning, guys. Coach Jackson here. We want to continue our sections on graphing functions, and we're going to start today with rational functions. We've already looked at polynomial functions, specifically quadratic. So now we're going to change gears a little bit and look at some rational functions. A rational function is a function that has a polynomial in the numerator and in the denominator of a fraction. So, first thing we want to do is find the domain. This should be a review from Unit 1. Okay? To find the domain, we look at the denominator. It cannot equal 0. So if we set the denominator factored form not equal to 0, we get x cannot equal -2 and x cannot equal 2. So if we want to write our domain in set notation theory, we're going to go from -infinity to -2, but we're not going to include the -2. We're going to go from -2 to 2, but not include either of those. And then we're going to go from 2 to infinity, but not include the 2. So that's how we would write it in set notation, the domain for this rational function. So we can plug in any number except -2 and 2, and we'll get an answer. And the reason that -2 and 2 do not work is because it would make the denominator 0, and that is undefined. So let's talk about where rational functions are undefined. They are undefined at what we call horizontal and vertical asymptotes. An asymptote is an imaginary line that a function gets closer and closer to, but never really crosses, except the function will never cross a vertical asymptote, and usually the function won't cross a horizontal asymptote, but it is possible. Okay? So you can cross a horizontal asymptote, it is possible, but no verticals. So rational functions usually have both, usually not all the time, but they can have both, and sometimes they have what's called a slant asymptote, which we'll also talk about in this section. Okay. So here's how we find vertical asymptotes, much the same way that we find domain. We're going to factor the top and the bottom, the numerator and the denominator, and then we're going to cancel if possible, and we're going to set the denominator equal to 0. Okay? So factor, cancel, set denominator equal to 0. So let's factor. All right, x squared minus 1 factors into x plus 1 times x minus 1. X squared plus 4x plus 3 factors into x plus 1, x plus 3. So the x plus 1s will cancel out, and we want to set x plus 3 equal to 0. So x equals -3 is a vertical asymptote. Okay? That's where our vertical asymptote will be. It's going to be a vertical line that crosses the x-axis at -3. Our graph may get very, very close to that imaginary line, but it'll never cross it. Note that what canceled out was x plus 1s. If you set x plus 1 equal to 0, you get x equals -1. So there's going to be a hole in this graph at x equals -1. So if you ever have any numerators and denominator factors that cancel out, that's where the hole is going to be located. To find horizontal asymptotes, we have to look at the exponents. We look at the biggest exponent on the numerator and the biggest exponent in the denominator. Excuse me. If they are the same, we divide the front coefficients. If the numerator is bigger than the denominator, then there's no horizontal asymptote. And if the numerator is smaller than the denominator, the horizontal asymptote is y equals 0. So there's only 3 situations. I'm going to run through an example on each one of them. Right? Looking at the exponents, I have a 3 here and a 1 there. We just never write it. So the top, the numerator, has a bigger degree. There's no horizontal asymptote. Example 2, both the exponents are the same, so we're going to take the coefficients in front. We're going to take the 3 and the 2, and we're going to divide it. So y equals 3 halves. There's going to be a horizontal asymptote at y equals 3 halves. Third one, we have an exponent of 1 in the numerator, an exponent of 3 in the denominator. The numerator has the smaller exponent, so there is a horizontal asymptote at y equals 0. Those are the 3 situations that you have to check for horizontal asymptotes. So let's look at finding the horizontal and the vertical asymptotes, the holes, and the domain for these examples. All right, first they want us horizontal asymptote. That's an exponent of 1, that's an exponent of 1, so we're going to look at 2 divided by 1 as being the horizontal asymptote, so y equals 2. We can't factor 2x minus 5 or x minus 2, so we're going to set the denominator equal to 0 and solve, and we get x equals 2. So there's a vertical asymptote at x equals 2. We didn't cancel anything out, so there's no holes in this graph. Didn't cancel anything, no holes. Domain. X cannot equal 2. Notice that's where the vertical asymptote is. So if it can't equal 2, how would we write that in set notation? Well, can't equal to 2 is negative infinity to 2, parentheses, union, parentheses 2 to infinity. We're excluding the 2. All right. Next example, horizontal asymptotes. We look at the exponents, 1 on the numerator, 2 on the denominator. That is a horizontal asymptote of y equals 0. We can't, we can factor x squared minus 1. It factors into x plus 1 times x minus 1. And what happens to the x plus 1s? They cancel out. So our vertical asymptote is going to be the x minus 1 set equal to 0, so x equals 1. That's our vertical asymptote. We're going to have holes at what canceled out. The x plus 1 canceled out. So if you take x plus 1, set it equal to 0, and solve, you get -1. So at x equals -1, there is a hole in the graph. Our domain can't equal to 1, can't equal to -1. You set the denominator not equal to 0. So x squared minus 1 cannot equal 0. Take the square root, we get x cannot equal 1 and -1. So to write that, we go from -infinity to -1, -1 to 1, and 1 to infinity. Using parentheses, we can't include the 1 and the -1. Example 3, horizontal asymptote. We've got an exponent of 1 here and 1 here, so they're the same. 2 divided by 4 is a half. So we'll have a horizontal asymptote at y equals 1/2. We can factor the bottom, but it doesn't really help us cancel anything out, but it will help us find the vertical asymptote. If we factor 2x, 2 times 2x minus 3 and set those equal to 0, we get a vertical asymptote of 3/2. Nothing canceled out, so there's no holes in the graph. Domain, take the original denominator, set it not equal to 0. We get not equal to 3/2. And we write that in set theory notation as -infinity to 3/2 in parentheses, 3/2 to infinity in parentheses. All right, I believe this is the last example. Horizontal asymptote. We have a 2 in the numerator and an exponent of 1 in the denominator. There is no horizontal asymptote. Can't really factor it, so the vertical asymptote is going to be at -1. X equals -1. Notice that horizontal asymptotes begin with y equal because they're horizontal across the y-axis. Vertical asymptotes begin with x equal because they cross the x-axis. We didn't factor anything and cancel out, so there's no holes. And then we need to look at the domain. Well, the domain, it can't be -1. So if we write that, we should use parentheses at -1 and exclude that. All right, so now we need to talk about slant asymptotes. And that's not going to take very long at all. You use long division to find the slant asymptote. Okay, that's why we started out with long division in this unit. So slant asymptotes are long division. Here's when you might have a slant asymptote. If there is no horizontal asymptote, which means the top exponent is bigger, if the top exponent is bigger by exactly 1, then a slant asymptote is going to exist. Here's an example. You got a 2 as an exponent on top and a 1 on the bottom. That means there's going to be a slant asymptote. Okay? What would the y-intercept be? Well, the y-intercept is where x equals 0. So if we put that in there, we're going to get 0, 0. X-intercept is where y equals 0. So if we plug that in, make this 0 and cross multiply, we'll get x squared equals 0. That's going to give us 0, 0. Vertical asymptote. Set the denominator equal to 0 and solve. There's no horizontal asymptote, but we determined since the top exponent's one more than the bottom, there's a slant asymptote. So we're going to use long division to find out what the slant asymptote is. The slant asymptote will be an equation. So if we take x minus 2 and we divide it into x squared plus 0x plus 0, putting in our 0 placeholders, we can do slant asymptote. What do we multiply x by to get x squared? We multiply by x. X times x is x squared. X times negative 2 is negative 2x. We put that in parentheses and subtract. Okay. What do we multiply x by to get 2x? Well, we multiply by 2. 2x here minus 4. And we'll put it in parentheses and subtract 4. When you're doing long division for slant asymptotes, we are not interested in the remainder. My slant asymptote for this will be y equals x plus 2. The remainder doesn't matter. Okay. So that's the slant asymptote equation. And why is it called a slant asymptote? Because it has a slope to it that is not not undefined or not 0. If it's not a horizontal asymptote or not a vertical asymptote, it's probably a slant asymptote. All right, one more here. What's our y-intercept? Well, to find the y-intercept, plug in x is 0. We get 0, negative 8. We plug in 0 here and 0 here. We get 8 over negative 1, which is negative 8. X-intercept, make the y 0. And if you cross multiply, you're going to get x cubed plus 8 equals what? 0. And if you solve for that, we get negative 2. If we solve for that, we get x cubed equals negative 8. If we take the square root, the cube root, we get x equals negative 2. That means negative 2 times negative 2 times negative 2. That gives us negative 8. Vertical asymptote, take x squared minus 1, set it equal to 0, and solve. We get 1 and negative 1. Horizontal asymptote, we are looking at an exponent of 3 here and 2 here. That's a difference of 1, the top being bigger. Not going to be a horizontal asymptote, but it will be a slant asymptote. So we have to do the math. So we're going to have x cubed plus 0x squared plus 0x plus 8. And we're going to divide it by x squared minus 1. So what do we multiply x squared by to get x cubed? We multiply by x. X times x cubed, x times x squared is x cubed. X times a negative 1 is a negative 1x. Put parentheses around it, subtract. You get x. Bring down my 8. Nothing else I can do. Not really interested in the remainder. So my slant asymptote is y equals x. The line y equals x. Here's all my asymptotes drawn. These are my two vertical asymptotes right here. Here's my slant asymptote, the y equals x. And I've plotted some points to show you what the graph would look like. There's a portion of it. And here is a portion of it. So they get close to the lines, but don't really cross. And then I believe that goes like that. Oh, no, sorry. This is going to be something like that. You might need to graph it on your calculator. That's about all I got for you today. If you need help, please come on the Zoom meeting, and otherwise email me and I'll try to help you. Have a good day.